All right, guys, welcome back to another episode of Within Tolerance. On this week's episode 18, we have Andrew McEwen on, and he is on Instagram. Make sure you follow him. We'll put links to his on the post on Instagram and then also on the links in the podcast. But he does all things 3D scanning. He's worked for some really cool jobs, and I'm going to let Dylan introduce him. So, Dylan, you want to take it away?
If you guys haven't seen him, he's Laser Scan Man on Instagram. That's kind of how I found him, and I've been following along for a long time, and we've seemed to just miss each other at every single big event, IMTS or AU or anything like that. But we're really happy to have you on, Andrew. And if you could just give a summary of who you are, what you do. I know you're at Altair now, so a little bit about that. I don't know much about Altair, so I'm really interested to kind of hear what you guys do on that end too.
Yeah, right on. Yeah, thanks for having me, guys. I'm actually pretty stoked about this. I've actually had in my mind to do a podcast, so kudos for making this happen. Okay, so a bit about me, Andrew McEwen. So I did come from the world of 3D scanning recently, and now I'm into the multi-physics simulation space. But I'm actually from Florida, and that's where I got my start working for a reseller of Z Corporation before it was acquired by 3D Systems back in the day. And then that exposed me to 3D scanning, became an AE, an application engineer in Texas, and ultimately got up to Seattle for a few years with Faro Technologies, migrated down to SoCal where I am now with Faro, and now just recently, the past few months, I've been at Altair Engineering, which does a lot. Our core, what we're really known for, is multi-physics simulation and optimization, and we can talk more about that going forward.
Great. So, what kind of got you? I guess what's your background? It sounds like you maybe were in ME, and then that's how you got into 3D systems. Or
Yeah, so I studied industrial engineering at University of South Florida, and the toughest thing is always trying to find your first job because people are looking for experience, and you're trying to get experience, right? So it just so happened I looked on Craigslist and I found this interesting opening for a junior application engineer, and essentially this person was a reseller for Z Corporation 3D printers, and they also had Z Corp 3D scanners. And so that was perfect because it was right on campus at an incubator, and I was able to just get exposure to some really cool things there. And I remember the first thing that I scanned was some remains, some human bones. They were unidentified, and through the power of technology, once we scanned it, we were able to use a digital clay tools system where these specialists were able to put death markers on the skull and carve digital clay to figure out what that person might have looked like. And then from there, I remember another job I did was we went and scanned an MRAP, which is a mine-resistant ambush protected vehicle, and I just thought that was awesome. I mean, getting to see some of these cool different things, where that data was then used to design an antenna that would fit to the vehicle. I've got a lot of stories, so
that's awesome.
Yeah, let me know if I start going deep down a path here. But yeah, it's been awesome. The world of 3D scanning has treated me well. I've seen different things every day. And what got me into Altair was so I've been kind of in this manufacturing 3D tech space for I don't know, probably 12 years now or so. And so I've been an application engineer doing the actual, using the actual technology. And then I've been on the sales side, and I've been all over the country. And what led me to Altair is, so I was in Seattle trying to figure out a way to get down to California where my in-laws are. And Faro actually ended up having an opening. But before that happened, I was talking to another company. It didn't work out. But fast forward 4 years later, the guy hits me up on LinkedIn and says, "Hey, I remember you." And I'm now at this company called Altair. And I actually had never heard of Altair, but two things that were really important to me was it had to be the right fit culturally, and it had to be something that I could get behind. Um, no, I give the power to the guys out there that can, sell cell phones or other commodities, but for me, it has to be something that I can really get behind. And simulation is really interesting because um, what it does is it allows a designer or an engineer to go through iterative designs very quickly. So if you think of like a drop test, right, where someone might design a product and then physically drop it to see how it performs, does it break or crack or whatever, in different conditions, how does it react? Well, that can get expensive. I mean, think about if you're designing the next iPhone and you drop 1,000 of these. I mean, that's costly and it's expensive. Um, but through simulation, you can do a virtual test, and you can do 1,000 of those, and very short cycle time. So that's really cool for a phone, but that technology expands into everything. It could be someone designing a child's car seat, and so where I play in that role is I'm really helping these designers get access to these tools so they can make safer products, more efficient products. It could be better performance. And as we get into kind of the holiday season where everyone's traveling, when you look around, everything in the world has been, designed by someone. And getting them access to these types of tools just help them create the better tools and do it in a shorter timeline. So
So is Altair? I had never heard of Altair either until actually you moved over and I saw it on your Instagram. Is like Ansys a direct competitor? Because that's a
they,
company I've heard of.
Yeah, they are. Yeah, Ansys is pretty well known, so it's a similar space. Um, so we go beyond just the simulation aspect and into the optimization. And so the difference is, if someone had a CAD file, for example, you could do that virtual test. You could simulate it into different scenarios. Optimization, though, says, okay, instead of creating a design and testing it, and then making iterative design and testing that and going back and forth until you're happy with the product. The software with optimization says plug in your parameters, let the software develop the optimized design for you. So you're really taking out all of that time in between. Um, and it's also allowing you to just explore different things. So take, for example, 3D printing. So 3D printing has really opened up the gates to allow people to manufacture parts that probably couldn't be done any other way, through traditional methods. And so with this type of software, you can say, make this like, have you heard of topology optimization? It's like a
Hmm.
free form shape that you couldn't really make in CAD otherwise. Um, so so going back to optimization, it's allowing you to just work a lot smarter. And then beyond that, we provide engineering staffing, so as your company grows, we can actually help fulfill those positions for you. And then we also are in machine learning, uh, and this is a new term for me recently, is think of like supercomputer essentially. So we can provide these 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 cloud solutions or these physical appliance where basically, like, if you go back a few months, I was happy with my Core i7, right, with 16 processors. Now you can get like 1,000 processors, CPUs, or even GPUs. It gets crazy because when you're looking at designing a vehicle and looking at the aerodynamics of it, there's a lot of information that needs to be crunched. And so having that computing power allows you to, instead of letting the computer run for, days on end, you're able to get that information, that feedback really quickly.
Totally.
So
Yeah,
yeah, so
that
we
makes
we
sense.
we do we do a lot, but it's really neat to see how it all comes together. Um, what one interesting thing that's kind of a hot discussion right now. Well, a few things. One has been the Internet of Things, and so if you if you think back to well, a few things. So Internet of Things, right? We're making all these things that are all connected, Bluetooth, Wi-Fi, and they're all talking to each other. All these products, all these electronics need to be designed, well. And if you think back to like the iPhone 4, there was this thing called Applegate where people were buying these phones, but they weren't really performing like the engineers thought they would. There was an issue with the antenna design. And the problem
Right.
was that people were saying, okay, all right, you, sir, your team, you're going to design the antenna, and the other team, you're going to design like the casing, make sure it's strong. But they weren't talking to each other. So if you're simulating separately, you're not getting the real world results. So that's where this term multi-physics or co-simulation into play, because if you can actually simulate how they work together, then they'll actually perform like they should in the real world.
So you're doing more than one simulation all at once, is what you're saying then?
Exactly. So you can actually look at mechatronics. So you can look at kind of the electronic side and the mechanical side and how they work together. Now, beyond that, you're seeing a lot of things being automated with robots now, and so what we can do is actually um, predict like life, like the life cycle of these products. So you can actually hook up sensors to robots and then use that data and collect that data to make predictive decisions.
Oh,
So
wow. That's something we talk about a lot on this podcast, actually, is automation and that as being the future of manufacturing. So that's really interesting.
yeah, absolutely, because it's all about being able to predict things instead of being reactive, right? You're able to be proactive, and then it's all about just trying to be more efficient. So, I mean, companies exist to make money, and so the thing is that generally you have competitors, and so if you do the same thing, you get the same result, right? But what happens if your competitor starts using some other technology that gives them an up in the a leg up? Well, the person that's adopting the technology uh, will be able to either make parts better, um, or make them quicker than you. And if you're competing for market share. And so, like like take example, a space that I worked with a lot was the side by side market. And so, if a new side by side or UTV comes out, um, a lot of people want to make, or sorry, a lot of people want to buy a new roll cage, maybe one that's a little bit stronger than the OEM cage.
Right.
Well, if you went and bought this UTV, do you want to wait like 12 months to buy a new cage? No, you want it now. And so the guy who can produce that cage can get that market share. And you're going to want to design that cage to perform better. So that's where simulation will come in, because there's only so much you can do physically. I mean, you can go build a cage and then try to drive it around and roll on it, but I mean, that's not very efficient. So if you
Right.
could run 100 different scenarios through a computer very quickly, you can come up with that optimized design. And then also you could look at, what size tubing do I need? Where's that trade-off between performance and weight, perhaps, or the cost of the material. So so this type of technology just allows you to work smarter. And the exciting thing for me is my career path has been going from manufacturing and then into prototyping, and then into scanning, where you could use the scan data to make a better prototype, and now into the simulation side, which is really the very beginning, because that's your bottleneck. If you don't have a design, there's nothing to make yet.
Right. Well, and it sounds like it's a good, especially talking about, side by sides or anything like that. It sounds like that's a good crossroads between both of your career paths there. I mean, people, I see plenty of automotive or aftermarket automotive people using 3D scanners to baseline their designs off of, and then iterating with simulation software and things like that.
Yeah, and so I've been privileged. That's where I spent the last part of my career, in that space with the designers and the engineers. But how I entered that space was more on the QA side, the quality assurance side, where um, you don't want to end up making 1,000 parts that are going to get scrapped because they weren't built within whatever spec. So the same tools that are used to capture the data to use in design are also used to essentially compare back to the original the CAD drawings. So to say, okay, I machined this hole. Is it the right diameter? Is it in the right spot? So a lot of times clients would use the tool for multiple purposes, and that was a very clear ROI because first off, a lot of OEMs would require the supplier to have some sort of tool to verify the parts to begin with. Um, but what I mean, what's the cost of if you produce 1,000 parts that are going to get scrapped? I mean, it's not just the scrap cost; it's all the time, the cost of the machines, the lights on, everything involved, and then I mean, are you going to miss your target? You know,
Right.
you
Yeah.
spent X amount of time, and now you've only got so much time allotted to get it right.
So how accurate are these 3D scanners then? Like how much QA can you do with them? Because I mean, I come from my day job. I started at as a quality inspector, and I've kind of worked my way up and through like the physical quality side, so CMMs, auto CMMs, scanning CMMs, all of that. But I've always looked at 3D scanners as like, oh, I've heard mixed things of like, oh yeah, you can definitely use them for quality, or oh, they're not nearly ready for certain types of aerospace parts or things like that.
Yeah, yeah, it totally depends on the application, right? And there's a few different types of technologies. So within 3D scanning, sometimes it's a general term, but 3D scanning, there's like white light scanners that use a fringe projection. They project a pattern onto the part. And then there's ones that are line based, like the Pharaoh used a line that was it was a laser line that blinked, and then that was connected to the articulating arm. And so the accuracies will vary. Partly will depend on the range. Generally, if you're capturing a bigger area, it's less accurate than a smaller area. Um, and then there's different technology behind each one. So the, the the scan arms of the world, which would be a portable CMM or portable arm plus a scanner attached, uh, generally you can get maybe like 2.5 thou, maybe more, maybe less, depending on the size. And then you've got things like laser trackers, which when you say scanning, they're not like really scanning in the sense that most people think, but you could totally take this SMR, which is just a target, and tell it, hey, take a point every X amount of seconds or every quarter of an inch or whatever length you set it to, and just kind of move that or scribe that over the part, and that'll still give you a point cloud, just not as many points, so it won't be as dense. But that would
Right.
still be
Yeah.
a type of scanning.
Yeah. I got to
Um,
play with one of those at the Hexagon Center in Irvine, California. I was there for training earlier this year, and they had one of their guys out with one of those. It was really cool, but also a little eerie having that eye follow you around, and then track your dot.
yeah, it definitely comes with experience. I mean, I know guys that can do that, just almost with their eyes closed. But it takes experience. But that's something I see though is sometimes people just are trying to use the wrong tool for the job. Um, I mean, if you're Boeing, you've got a few dozen of everything or more. But for the smaller mom and pop shop, you use what you get, and that's why it's really important to consider what type of applications or what type of work are you going to be doing. Majority of the time, I'd always ask my clients, let's focus on the 80/20, and then occasionally maybe you can use this for something else. But just know that it's not, nothing is a silver bullet. So I think that's where it's important to make sure that you're working with someone like an account manager that really understands what you're trying to do and can offer the best solution. And even if that's not not theirs. Um, I've seen people in my career where I walk in and I try to understand what they're using, and it's like, what? That's just not the right tool. And trying to force a square peg in a round hole kind of thing.
Right. Yeah, you're destined to fail from the beginning. I gotcha.
So, Andrew, I had a question for you that I just kind of randomly thought of. So, these companies that you've worked for, like Altair and Faro, like after hearing you talk, I kind of have an understanding of what you do and what the companies do that you work for. What are some of like the customers? Is it like Apple that's coming to you and saying like you said, like test an iPhone being simulated dropping, or is it like Tesla coming to you and saying test out our airbags, or like for simulation purposes, or the scanning side of things? Like what kind of customers do these companies get? I'm just trying to
Yeah.
understand better, kind of what do they offer to the world.
So first, my first answer would be I plead the fifth. I can't confirm or deny under NDA, but generally because my career has spanned over multiple majority of the country actually, and multiple companies. So it includes virtually everyone. So if you look at the
Okay.
scanning side, I've worked with everyone from a one person company up to the Fortune 500 companies. At the end of the day, it just needs to make sense. And I remember a lot of clients would say, "Hey, we're not Boeing. We don't have like just cash flow everywhere." But the way I looked at it was, if like the idea really isn't necessarily that you're going to use these tools every day, all day, because if you were, then maybe they're like for scanning. If the end goal is to help you produce a better product faster and you're having to scan all day to get the information, then that's not really helping you be more efficient. The idea should be that you only use it for an hour or two a day, a couple times a month. And if that helps you get a product line out faster, do the math. One, if that helps you beat the competition to get that market share, or if it helps you create a product that's going to be worth, $100,000, and you dish out one or two more of those a year because of the accelerated timetable, then that's your ROI. Um, so yeah, it's varied. A large portion of my career has been with aerospace. So there has to be essentially a paper trail. Everything has to be validated at every stage. And so at that point, it's just finding the tool that helps you do that most efficiently. Um, the automotive space, as far as building cars, that's really the same scenario. And then you've got guys like Jay Leno, right? Where they don't have Jay's not um, trying to make his own vehicles. He has vehicles where it's one of one, and there's you can't go to you can't go to Pet Boys and get a replacement part. So you have to 3D scan it, reverse engineer it, and then build a new one.
So I guess that kind of rolls into that question we have on the list. Who is, the coolest or most prominent customer you work with? I mean, I've seen pictures of Jay Leno, Chip Foose, Magnus Walker, Stefan Papadakis. Like you had a whole bunch of people on your Instagram it was really cool to see that you've worked with.
Yeah, some of those were within our space. They weren't necessarily my direct client, but Jay Leno was definitely awesome. I remember I met his chief engineer Jim Hall at SolidWorks World a few years back, and he asked, "Hey, do you want to come by the garage? We're going to do some taping." Which isn't really we don't really videotape anymore. We don't use VHS,
Right.
but yeah, they were recording for the Jay Leno's garage YouTube channel, and that was an experience because you look around and he has a whole room just for fire trucks. I mean, we're talking steam engines, wooden spokes, and it's just funny. You never know where life takes you, and so that's why like things like this and LinkedIn and Instagram, you just never know. I remember I had I had connected with someone when I lived in Florida who was in Washington, and then I ended up moving to Washington, and they were a client. Um, but yeah, so Jay Leno is definitely at the top there. I also worked with Jeff Dunham. Uh, Jeff called,
Oh, really?
yeah, the ventriloquist on Comedy Central.
Yeah, yeah.
So he called me up. He said, "Yeah, this is Jeff Dunham." I'm like, what are the odds? Like, that's cool, you know. But then he's like, "No, Jay Leno referred me." I'm like, "Oh, the Jeff Dunham. Okay, what can I do for you?" Um, so his dummies or puppets that he uses, they're all custom made. And so he did a little YouTube video for us, and essentially he carves a new character out of clay, and then needs to digitize that, so then he can scale it down or modify it, hollow it out, and 3D print it. And so what you're actually seeing is the the structure side, the physical side. That's a 3D print, and then he adds on hair and paints it and whatnot from there. So that was awesome. But yeah, I'd say for me in general, the whole car scene, the whole SEMA show is just awesome, and because you'll see, there's obviously like the big guys, the OEMs, are using this for every stage uh, from designing to inspection, but also you're seeing all the smaller guys. You look on Instagram and say, "Wow, this guy's got 100,000 followers. This is legit." And then you show up and it's like three guys in a garage. Um, and so at that point, it's how are you competitive? Well, you've got to use tools to stay in the game, and 3D scanning is one tool that can help. Um, and same thing for all the suppliers. I mean, there's guys that are bidding on the same work, and it's like, well, what separates you from the next guy? Well, I use technology that can help ensure that we're going to be able to pro- provide you with the parts uh, that are going to be spec'd the first time. They're not going to leave our dock. You're not going to receive a bad shipment because we have this process in play. So because a lot of times it's like, oh, well, you've been in business for 50 years, 75 years. And it's like, that's great. Keep doing what you're doing there. Um, but the client's going to expect, they're going to need to know that you're going to be able to keep doing that, right? That they're not going to be the ones that end up with some bad parts, because they might not even be the end, the OEM. They might be the person in between. Maybe they're the tier 2 supplier. So they've got people they have to answer to as well.
Right.
So
Right. Well, it's not like parts are getting any easier to make either. I mean, we're not going to more basic shapes. We're only going to go more free
yeah.
form and organic and all that.
So that's the other thing, right? Because you mentioned some experience with CMM. So if you take like more of the traditional gantry style CMM, where the machine is touching a point, moving, touching another point, that's great, because if you were to look at flatness of a part and you pick 5 points, um, that might be okay. But when the part is freeform and it's organic, if you only pick 5 parts and it's a freeform shape, I mean, that doesn't really tell the whole story. Versus if you can scan 100,000 points on that area, you can actually see where's the dimple. Is that part crowning or shrinking or warping in such a way? Because okay, so half of it is my part passing or failing, but the more important part is what's happening to the part. Like if you just knew that 1 out of 100 points is off, that just tells you if it passes or failed. But with a color map, taking a 3D scan, comparing it back to the CAD file will tell you, okay, this area is lifting in this corner. Then perhaps you can go back to the machine and do diligence and understand, okay, why is that happening? Maybe there's an issue with the fixturing or whatnot. So it's really helping you to not only identify if there's a problem, but what's going on, so you can really quickly make the adjustment and move on. And then with the simulation and optimization side, it's just again goes back to uh, trying to shorten that cycle time, and so when I look at why does a person buy a product, it could be aesthetics, it could be um, brand recognition, performance. And so simulation really plays with all of that, because like sometimes you might pay a premium for a part because of the history that goes with with that brand. And so a customer is expecting that. Well, how can they keep delivering on that? Is you need to design something that is not going to fail, right? Because the cost of if you lose that, I mean that's huge. I mean, your company's been around however many years. That's the ROI, is maintaining that.
Totally, yeah, that makes complete sense. So, what would you say? I mean, both 3D scanning and simulation. What do you think the top three mistakes are that people make, or the biggest misconceptions that people have about those technologies? Because I feel like people look towards, especially 3D scanning, as like a catch-all, like, oh, it'll do this and this and this and this. When
Yep.
really, it sounds like it's a lot more specialized, especially depending on the product that they buy. So,
Yeah.
what would you think the top three mistakes are that people make?
So I've been in that space for a while, and there's definitely competitors, but I think we can all agree that the perception or expectation a lot of times is that there's this one button click, like, oh well, I saw a video, and I might I might be contributing to that, but it looks like you just scan it and you're done, and it's CAD, or I've got this report just automatically. But there's behind the scenes that lead up to that. Now, once you have done some of that, there are some tools that will help automate that. There's some intelligence behind it, but there's an expectation that things are just automatic. So I think that's one misconception. Um, Another is I think definitely on the simulation side is that maybe the client thinks that we don't need it, or it's just too expensive, and it's just that's for the big guys. Um, but going back to that question of, I mean, what happens if you don't? So if I mean, there's definitely upfront costs with buying anything, software or hardware, um, but if you're not able to shorten that cycle time down, I mean, what's what's that cost if you lose that market share to your competitor, or that um, you design this and you think it's going to be fine, but in the reality, like let's look at fatigue, for example. If you were to make a part and you think, okay, this is going to last X amount of years, I mean, how do you know that? Are you gonna test it for that amount of years? I mean, that takes a lot of time. Maybe you don't. You just make some assumptions, and then that part doesn't last that long. That could be, that could affect your brand. That could affect recalls. Um, what's the cost if you have a recall? What, you know,
Right. Oh yeah. Yeah, it can be a giant.
so generally, with both technologies, mistakes that I see on the customer side is just not working with an account manager. I mean, the account manager's role, I mean, a lot of people think, oh, you're just a sales guy. You're just trying to push some product and make a quote and down your throat. But really, in my mind, a good account manager is really just trying to understand. I mean, what are you doing today? Where are you trying to go? You know, what's your current process like? And so yeah, not working with an account manager, because the account manager is the one that, if we can identify that this type of technology is going to be beneficial, we can really help you understand what types of things you should be looking for, and really how to make this happen. So one thing, as a sales guy, I've always seen is, someone just wants what's the cheapest thing out there, but the cheapest thing may not necessarily be the best fit. And then sometimes it means not even buying. If the numbers don't make sense, and they don't make sense, maybe it makes sense to do a trial of some sort. Maybe it makes sense to use a service provider at the moment until you're ready to really do it right. So like, I saw a lot of people would buy these kind of consumer grade 3D scanners, which don't get me wrong. I mean, I love 3D scanning and I geek out on this stuff too. But when we're trying to use it for an actual, um, production application, if it's not accurate enough, you just, yeah, it was only a couple grand, but you kind of like, I saw so many of these scanners just like, okay, how has that been working? Well, we bought it. We never used it. It's sat in the closet. Um, so if you work with an account manager, then, if they're doing things right, they're really going to be acting more as a consultant and trying to understand, what makes the most sense. Is the timing even right? Does it make sense to, like, going back to using the right tool for the job? Does it make sense to use a laser scanner? Maybe you should be using a laser tracker. Um, so yeah, they would be looking at price alone, not working with an account manager, getting the wrong software. I mean, the hardware is only as good as the software behind it, and I get it. Software can be expensive. It's all relative. Um, but the software is where a lot of this automation comes in. So take an example. If you're using a scanner to do a QC, to do inspection, there's some software where you would measure one part and then you get another of the same part and you measure it and do the same thing, exactly the repetition. But some software allows you to automate that. So you would set it up, you've got your CAD file, you say, okay, this is how I'm going to align the part. These are my tolerances. This is what I'm looking for. I'm looking at these datums. I'm looking at the position of this circle, how these planes are parallel. You set all that up and you scan it. And then the next part, you just scan it. And the third part, you just scan it. And so all the setup is being done. So you only have to do that once. And so that software might be a little bit more expensive, but it's going to allow you to run like 90% faster. So really using the right software for the application.
So what software would you recommend? This came up recently. I think it was another podcast. They were doing a live stream on Instagram, and somebody was asking about 3D scanning. What would you recommend for turning reverse engineering scans to CAD?
Okay, so budget does come into play, of course. It also depends on your current process. What CAD do you use? And then are you going to be doing more of inspection or reverse engineering or both? So there was a plugin for SolidWorks called Geomagic for SolidWorks, and there's a few others out there. That's not necessarily like the Cadillac, but if you're already using SolidWorks, it's an easy integration because then the learning curve is very small and it's more affordable. So that's a good one to consider. Geomagic Design X for reverse engineering is they essentially invented reverse engineering, and that was always my go-to because it allows you to scan and then create a CAD with a history tree, and so you can make changes. You could say, for example, you're 3D scanning a part, you want to make a part like that but better because the current way it was manufactured 50 years ago was different. For example, give you an example of like a UTV part. So an OEM UTV part might be made using, maybe the part was stamped, or maybe it was casted. Okay. Well, you have a UTV aftermarket company that doesn't have access to casting. What they have access to is a CNC. Okay. So instead of reverse engineering it and try to make this casted freeform shape, you make a part that is like that. It has the same hole positions, fits in the same space, but is designed differently. It's 3D Systems Geomagic allows you to create that. And then let's say you just want to make it a little bit thicker. You could have a Rev 2. You can go in that history tree and make the change without having to like 3D scan the whole part and build it from the ground up. Now, if you're going to use both, inspection and reverse engineering. 3D Systems has an inspection tool as well called Control. And so there'd be advantages to going with the same company on the software side because there's going to be cost savings, bundle savings. If you're going to go exclusively inspection, Polyworks, it has really been the market leader in that space. And they actually work with traditional style CMMs as well in the past couple of years.
Okay.
And what's really interesting about Polyworks is that there's that automation side to it. They also have a free viewer. And again, I don't work for these companies, so this is I'm not speaking on behalf of anyone, but this is just my personal take. So Polyworks has been in the automotive sector, done very well. They have a free viewer, so at that point, it's not just about does the part pass or fail, why is the part failing potentially, but improving communication. Because what I saw a lot was, say the customer receives a part and they use hand calipers or whatever tool, and they say, hey, the part's bad. Well, what is the supplier going to do? The supplier says, well, we think it was good when it left our dock. So who's right or wrong? I mean, is the supplier just inspecting it incorrectly? Well, if you have a digital and traceable 3D scan of that, what you can do is provide the client the free viewer. You can get on the same page, say, hey, let's hop online, take a look at the same scan, spin it around in 3D, look at it. And at that point, it was always like assurance for the supplier, because if you say to the client, well, how did you measure? And they say, well, I took 2 points with a hand caliper, and it was a plastic piece. Well, how much pressure did you apply, and where did you measure it? Versus the supplier, well, we used a 3D scanner. We collected, 500,000 points. We're a little bit more confident, right?
Yeah, exactly.
So that was like the headache medicine. So yeah, those two brands were really powerful. Some people were not doing, freeform shapes, and they just wanted something really simple, and they would use like Faro has a Cam2 Measure 10 software. Hexagon has their PCDMIS software. I wouldn't say either of those are the best, but
yeah, as a PCDMIS user, I would definitely agree with you there.
Yeah. But one term I heard recently is one choke to throat. So as like a buyer, just having it all under one house just made it easier, because I would see, okay, this system's not working right. Okay, what is it? The software? Is it the hardware? And if you just have one source, then it's maybe easier to manage. So that's okay. So that's inspection. That's design. And then there's some other applications that are kind of out there, right? Like we had scanners that would scan in the whole room, and that could be used for like video games or documenting crime scenes. I mean, capturing color where you can see the blood splatter. So the world of 3D scanning, it's really evolved. I mean, I was seeing new applications all the time. And
so what's the most interesting application you've worked on or seen used? I mean, it sounds like they can kind of go everywhere, but what do you find the most interesting?
This is going to be good.
There's lots. I've seen. I mean, I just I'm into like car kind of stuff. I remember scanning another MRAP, and it was suspended over my head, and this thing was several tons. That was fun. The most interesting,
or maybe the most out there, like what's the most atypical application you've ever seen for 3D scanning? Because I feel like everybody knows about the inspection, everybody knows about the reverse engineering.
Again, I'm not affiliated with anyone, but I have. It wasn't me personally. I've had colleagues that were working with the adult industry space, trying to make realistic pieces. So that was interesting.
That is definitely atypical. You hit the nail on the head there, I think.
Yeah, yeah, yeah. Never ended up going to any of those trade shows. Um, but yeah, I mean, seeing. Uh, let's see. Gaming has been an interesting space. There's games out there like first person shooters, and you look at the like the essentially the guns in the game, and they look kind of real because they were 3D scanned.
Oh wow.
Yeah, and even the spaces now, right? You can 3D scan the physical space. Oh, one yeah. So I remember working with another guy. You can read his story. Um, he was using lidar, and he connected this to a go kart, and in real time, throwing on these like VR right goggles, essentially playing Mario Kart, like physically driving a go kart, but then having that linked and tracked real time to a virtual space that was 3D scanned.
Oh wow.
Yeah,
That sounds bizarre.
yeah. So
That is really cool.
I mean, yeah, it's a very cool industry. The I've been wanting to write on LinkedIn actually about this industry because it's something I kind of fell into. Like, you don't really go to school, like actually even just um, like GD&T. A lot of people don't go to school to become like a quality manager, quality engineer. Like, it's kind of like you go to school for something else and you kind of end up in it. It's a very a niche space. Um, where was I going with that? But yeah, it continues to grow, and I think the like 3D printing. I think the technology is getting more widely adapted, and that's really opening up the gates for some players that in the past it wasn't within reach. I mean, I remember at Faro we came out with a system that was half the price of some of the others, and that really opened up the doors for some of these smaller companies that in the past was just out of reach. And so with that, I think you're going to continue to see more and more adoption and interesting applications.
Awesome. So what do you think is next for simulation and 3D scanning? I mean, you guys are doing so much right now, but with 3D printing and all this, like what do you think the next, I don't know, the next level for all of these technologies is? I mean, you're kind of deep in it, so you've seen where it has been and where it's going and all that.
Yeah. So with 3D printing, I mean, we're already seeing it, right? I mean, there's companies that instead of in the a decade ago they'd buy one printer, and now they've got farms of printers, and you're seeing printers making printers now, um, and and so it's just I see more wide adoption. I see the materials are improving. You're seeing a lot of different types of DMLS, different types of metals come out. So I think that's kind of the next wave that we're already entering is the metals, where we've taken it from a prototype to now additive manufacturing. These are the end use parts. So I think metal's huge. I know there's a lot in aerospace where they're testing these parts out for uh, what's considered flyaway parts. And
What about 3D scanning? What do you think is just more resolution, more accuracy? Is that
yeah,
the
that's
next
that's
step for it,
always
or?
yeah, that's always the name of the game, right? Getting something lighter, more accurate, more robust that scans a very large field of view, and so that's where generally the larger the focus, the larger the field of view, the larger the scan, the less accurate. But when you look at things like going back to the fringe projection system. So they use a projector and cameras. Well, the cameras are getting more higher megapixel. So I think we're already seeing that, year after year, being able to capture more detail. I mean, the Faro scanner, we were scanning fingerprints. I mean, and
Oh
so
wow.
I think ultimately, The next phase would be able to look at surface finish. We weren't quite there, but I know that's something from that I heard from a lot of machine shops is being able to use that tool for that dual purpose.
That'd be
Um,
amazing.
so yeah, yeah, higher resolution, higher accuracy. I think the price will, I think the price will continue to come down, but at the same time, it'll remain the same. You'll see more consumer, um, and you'll see some prosumer scanners. But I think what'll happen is the price on the professional grade will stay around the same price, but it'll just continue to improve. So there'll be a spectrum for anyone. Um, but the other interesting thing is with like machine learning and just computing power. I think you're going to see uh, just more adoption, and I imagine that there's going to be uh, some sort of network of file sharing. Um, there's there were so many times that I had clients scanning the same thing. New Ford Raptor came out. When new Ford F-150 came out, everyone's trying to make
Hmm.
a bumper for this new truck, right? They're scanning the same thing. There's going to be a system out there where someone has scanned this truck and they're going to be able to sell that data. That
Yeah, that's smart.
right. I mean, and so and I've seen other organizations that have been sponsored to go scan like artifacts and monuments around the world, um, so that other people have access to that. I mean, because the thing with um, artifacts is natural disasters. So if there's some some monument or some statue out there that's made in thousands of years ago, and then a tsunami goes and wipes it out, or a hurricane, that's lost. So being able to digitally scan that, like the Smithsonian's already doing that. They have all the different types of scanners. If you Google, uh, NASA 3D scanner Smithsonian, you'll find um, some really interesting 3D scans, and that they're also publicly available for you to download and even 3D print. Um, but there's only so many people working at Smithsonian. I mean, imagine if everyone was walking around with 3D scanners like that with their cell phones, and
Yeah, oh,
collectively.
yeah,
And you're
it's
already seeing
definitely
some
starting to
of
get
that.
there.
But
Yeah, yeah. I mean, my phone has a time of flight sensor, and you can get rough 3D scans from it and stuff. But like you said, I'm sure with more computing power and better cameras and all that, it's only going to get better.
yeah, yeah, exactly. And on the simulation side, it really is the optimization, because the traditional method has been design a part, test it. But now with the computing power, the software is able to tell you, okay, what space, like how big does this part need to be, where the holes need to be, and then the software will tell you, okay, this this is the optimized design. It fits within the space. It's going to mount because the holes are in that position, but it's been lightweighted. So instead of being a solid block, we reduce 70% of the material, which if it's going on an airplane, I mean that's huge. Weight is everything. And then it still meets your requirements. It's still strong enough, and robust, or whatever parameters you set up. Um, so yeah, optimization is there, and then I don't really focus in my role as much, but Altair is definitely working in the machine learning space. That is some really interesting stuff. Um, so one thing we talked about actually a couple weeks ago at our Altair conference was this concept of machine learning, where someone would be able to take apart and actually tell the computer, okay, here's 1,000 of this types of part, and then if you put in another part, it will be able to identify what type of part it is. So if you threw in a spoiler, you gave it 3D data for 1,000 different spoilers. Eventually, if you came up with another design for a spoiler, it would identify that's a spoiler. So if you look at it from like creating a database of different types of 3D parts, you could have nuts, for example. You could type in nuts, and then it would provide you, okay, here are all the different step files that are nuts, without you actually having to call or type them as nuts in the naming convention or save them into a certain folder. Like they could all be anywhere on your computer, and it would search, and it would, by looking at the 3D data with machine learning, it would be able to categorize that for you.
That's crazy.
So that goes
That'll be
back
really
to
cool.
if there was a whole network of everyone making these 3D scans, you could type in theoretically, I'm looking for a statue, and it would go scour the internet or wherever this database is, and it would provide you everything that it believes is a statue. Then 3D print one for your home or whatever.
Wow. That's crazy. That is really cool. Well, do you have any other remarks you want our listeners to know about scanning or simulation, or I think we ran through all
Yeah.
of our questions pretty quick.
Oh, yeah. So this, like, I'm new, so everything's awesome to me. I mean, I think the world of simulation is nuts. So like, so when I entered this world, I thought, okay, you could simulate a part. Okay, does it, how is it strong enough, right? But then you can also look at multiphysics, where okay, it's strong enough, and it's also aerodynamic enough, and it's going to be quiet enough. And you look at all these things combined. But generally, that takes a lot of time. So the way that simulation works is you have generally a 3D file, CAD file, and then you do what you call meshing, right? Which is kind of like 3D printing. So it divides everything up into quads and triangles, and then you kind of set the system up, tell it what parameters, and you let it crunch. And so if you take an assembly of parts, we're talking it could be days to run. Well, there's this new technology, which is a meshless technology, which takes things from days to minutes.
Wow.
That's something, if you're like a mechanical engineer, you definitely should check out, because it's, I hate to say the word game changer, but it's nuts. And so the idea of just trying to take a concept, a design, and just kind of run it through some initial tests, that gives you really quick feedback that you can say, okay, I'm going down the right path, and then maybe you do some optimization from there. But yeah, check out Meshless FEA. That's this type of technology. And I mean, Altair is not really a sales-driven company. It's more like an engineering company. I mean, everyone is like, all my colleagues are like PhDs, um, and and so they acquired this technology, and they were very skeptical. And that's what we're finding is most people are super skeptical. But check it out. It's called SimSolid. And if anyone wants more questions, I'd be happy to help them out. But yeah, that's my little plug there. I appreciate
Awesome.
you guys at this time. This has been awesome.
Yeah, thank you so much for coming on. I don't feel like both Peyton and I were kind of naive about the whole world of 3D scanning. Like I've always been interested in one, and I've always wanted one for selfish reasons, to reverse engineer stuff for my bike or my car or whatever. But
Yeah.
it's great to get to talk to somebody in the industry who's had so much experience with it, and we really appreciate you coming on.
All right, guys, that's my cue. Time to
Yep.
go walk the dog.
Well, thanks, Andrew, and yeah, everybody go check out Laser Scan Man on Instagram. Give him a follow and join the world of 3D scanning and simulation. Thanks, Andrew.
All right, cheers.